Okay, so we just learned about using integrals to get things like distance and displacement. You can also use integrals to find the average value of a function, or in this case, an average velocity. Like if you knew that you covered 300 miles in 5 hours of driving, you know that you would have 60 miles an hour as your average velocity, right? And so let me back that up. Wait a second. My average velocity, if I know how far I went, that would be displacement. So this, by using displacement versus distance, it's kind of doing the keeping it all averaged out and paying attention to that going backwards versus forward. It's your displacement divided by your time. Well, we know we find displacement by integrating our velocity. So we would go for our velocity from A to B, and then our elapsed time would be B minus A. Like if you went from time 1 to time 4, it would be 3 for your elapsed time, or B minus A. So let's take a look at this. So here is this is the equation that I've graphed it here. This is x to the 1.5 plus 2 sine 2x. And let's say this is some, I don't know what sort of thing in meters per second. So, and my graph is going from 0 to 5 seconds there. So if we want to know the average velocity of this, all we need to do is integrate from 0 to 5 seconds of that velocity. I know I used x instead of t just because, I don't know, I like x's better. And then we'll divide it by 5 minus 0, or just the 5. I'm writing the minus 0 there just as a reminder that, yeah, that's really what we're doing. It's not just the upper bound there. Okay, so I have this guy. And I know I could totally integrate this myself by hand, plug in the 5, plug in the 0, and subtract and all that stuff. I'm kind of feeling a little lazy, efficient. So math 9. 0 to 5, y1, oops, not v, x, hit enter, it'll think about it, and then divide this guy by 5. So my average velocity is 4.8399, or 4.839, yeah. And if you think about your units, since this is displacement, like integrating velocity would get you meters, but then the elapsed time is in seconds. So this is still in meters per second, which makes good sense. So let's take a look at this graphically. I'm going to store this number as A. And I'm actually going to graph it as well. So I'm going to do y2 equals A. And good, I didn't regraph the other thing. So what this means in terms of like a graphical thing, if I look at the area of that red rectangle that's between 0 and 5 seconds, that region is the exact same area as this region that's underneath that curve between the curve and the x-axis. So basically this chunk that's above and the chunk that's extra, those are equal areas. So another way to look at this would be like if this was some creature, the distance they would go in this 5 seconds would be exactly the same as the distance that somebody going the exact same, like going 4.839, just on a constant. So that is finding average velocity, or an average y value. It's really straightforward. An average y value is just the integral from a to b of some f of x dx divided by b minus a. So if you're ever asked to find the average value, this is what we're doing, or and if that is the average y value that we're talking about. So there we go. That's part 2 of our day, and we are good to go.